Okay, so in the name of God, most gracious, the most merciful, my peace be upon you all, everybody. In this video, we're going to speak about the Nsc June 2019 Math Paper 1, Question 4. Okay, so I would advise you to download the paper and follow with me, please. So, given the exponential function g of x equal to a half to the power of x. So, they're giving us g of x equal to a half to the power of x. So 4.1, they ask us, write down the range of G. So what's the range of G? Okay, so out first, come and draw a sketch of the graph. So there's your Cartesian plane, x and y axis. So the Q value is 0 plus 0. So therefore, 0 is our asymptote. Okay, y equal to 0. The A value is a fraction, so it's a decreasing graph. So the graph will look kind of like that. Okay, g of x. Just go back to the introductory videos to understand why it is like this. So the range of the graph is all the y values. That's the y-axis. So you can see that the range of this graph only lies above the 0 mark on the y-axis. So the range is going to be y is more than 0. Y will never be equal to 0 because y equals 0 is the asymptote and the graph does not lie below the 0 mark. 4.2. 4.2's question is determine the equation of g to the negative 1, which is the inverse, in terms of y da 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 da. So we know that g of x is y is equal to a half x. The inverse, you swap the x and the y's, so we're going to get x equal to a half y. It's about y. Now we're going to do the log story. So with the log story, all that you do is that the exponent becomes the answer. So we're going to get y is equal to log. The base stays the base. And you put the x there. Log to the base half times x. Okay, that was fairly simple. So y is equal to log to the base half times x. 4.3. Is g to the negative 1 a function? So is this a function? Is the inverse of g a function, yes or no? So let's draw a rough sketch of the inverse of g. So if this is g, right, and we draw the inverse. So if we reflect this line over the line y equal to x, and you get the inverse will kind of look like, let me just see, this. Okay, the inverse will look something like that. Okay, so the question is this a function? So this is g to the negative 1. Okay, and this is g. So is this a function? So the first option is, does it pass the vertical line test? We take the vertical line and we draw the vertical lines. So the vertical line touches the graph once, so it passes the vertical line test. So the answer that they have in the memo, or because I know we want to know how to answer it exactly how the examiner wants it to be answered, so we can say that okay, so we can just basically say that the vertical line cuts. So basically we can say that the vertical line cuts g to the negative 1 once. That's all we can say. The vertical line cuts the graph once. Okay? Or what you could have also say is that for every x value, there is only one corresponding y value. And you can see here that for every single x value, there's only one y value. Okay, so we could have also say that for every x value, there is one y value. Okay, or for every x value there is one y value, or there is a unique one y value. Okay, so that would be correct. Okay, so I also spoke about this in my video on is this graph a function. So let's go to 4.4. So for 4.4, they ask us, let me just go to it quickly. Now they say the point M, so they say the point M, which is A and 2, lies on the inverse. So it lies on G of to the negative 1. Okay? So question 4.4.1 say calculate A. So remember, A is the x value, right? And we've got the y value. And the equation of the log is y is equal to log of x. So remember, if you're looking for the x value and we have the y value, just substitute the y value into this equation and solve for x. So we got 2 is equal to log of x. Now we just try to solve for x. So what we can do is that we can change this and try to convert it in the exponential form. Okay, so firstly what we do is that we switch the x and the y's, we swap it around. So we get x is equal to log of do we do it so? No, we don't do it so, sorry. We say x is equal to, the base remains the base, and that y becomes the exponent. Okay, so, and you can just follow the video on the introductory videos on exponential graphs. So what's the half to the power of 2 is equal to 1 over 4. So therefore the x value is 1 over 4 and 2. So therefore a is equal to 1 over 4. Okay, in this graph over there. Okay, so that's very important to understand. Okay, now 4.4.2, what do they ask us? They say that M dash is an image of M, right? And they say M lies on G to the negative 1. Then they say, what are the coordinates of M dash? So how do we approach this particular question? So this particular question, what we first do is that let's first have an understanding of how our diagram looks like. So our diagram looks like this, where we have our original graph, which is G, like that. Okay, that's G. And our inverse, we can clearly see that our inverse, so that's the asymptote of the inverse, and the inverse is going to look like, kind of look like that. Okay, so they say they say M dash is an image of M. Now what's M? They say M lies on the inverse, and there they already said by 4.4 that point M is on the inverse, so that's a quarter and 2. So a quarter and 2 lies around about here. Okay, a quarter and 2, that's M. Now they say that M dash is an image of M. So M dash is basically an image of M on the original graph. Okay, they say they said here that M dash lies on G. So M dash lies on the original graph. So if you want to get the image of the coordinate, all that you do is that you switch the x and the y values. You swap it around, because you're reflecting that point on the graph y equal to x. So all that you do is that you just switch the coordinates around. So what are the coordinates of m dash? It's going to be 2 and a quarter. That's all you do. So they say, so m dash is an image of m. So m dash is an image of m. They said which lies on G. So m dash lies on the original graph. There's m dash on the original graph. The image, if I want to get the image of a coordinate over the y, over the image of over the y go to x, you just switch the x and y values. So that's the coordinate of m dash would be 2 and a quarter. Okay, that's basically it for that part. Okay, in the last question of 4.5, they tell us, they say that if h of x is equal to g of x plus 3 plus 2, write down the coordinates of the image of m dash on h. So they say write down, so they're asking us what is the coordinates of m dash on h. Okay, so what are the coordinates of the image? What are the coordinates? Write down the coordinates of the image of m dash on h. So m dash lies on the original graph, okay, and the original graph is G. So h of x is a translation of G, okay, and we can see here that we added 3 to the x, and we added 3 to the this is the p value, right, and we added 2 to the q value. We added 3 to the p value, and we added 3 to that q value. But anyway, so they say the coordinates of the image of m dash on h. So what is m dash? M dash was 2.5, right? Plus 3. What does plus 3 mean if you plus 3 by the x? Plus 3 means we're going 3 units to the left or to the right? To the left. If we're going 3 units to the left, just have a look at it. If we're going this, we take this graph and we're going 3 units to the left. Do you see that if you count with me 1, 2, 3, the new x value is minus 1. From 2 it's going to go to minus 1. So therefore, the new coordinates, so this was the coordinates on G, right? But now we have to get the coordinates of m dash on H, which is the reflected graph. So the new coordinates would be minus 1. And what would be the other one? So we see 2, it was actually saying 2 minus 3. You understand? Which give us minus 1. Because we're going 3 to the left. And then because we plus 2 to this q value, we're going 2 up. So if you look at this y value here, and we're going 2 up. We're going 1, 2 up. You have to add 2 to a quarter. So what's 2 plus a quarter? What's 2 plus a quarter? 2 plus a quarter is equal to 2 quarters. And if you put that into a mixed fraction, you're going to get 9/4. So therefore 9/4 is the new y value of m dash after we did the translation to h of x. Okay, so that is basically the answering the question of what is the coordinates of the image of m dash on h. Basically, what is the new coordinates of m dash on h, right? H is the translated graph, right? So that is the coordinates. Okay, So we went 3 units to the left. So we can call it m dash dash, m dash dash, because this is m dash and that's m dash dash. Okay, it's because it's different coordinates. Yes, that's one coordinate. That's like a translated coordinate. So we have h of x is gg. So g is the original graph. So we have to take m dash because m dash lies on the original graph of g. So that is 2. So you can see if you plus 3 to the x, we're going 3 to the left. If you go 3 to the left, you must say 2, then that x value minus 3, which is negative 1. And the y value, we're going up. We're adding 2. So you must take the 1 over 4 plus 2, or 2 plus 1 over 4. Which you got 2 quarter, which is 9 over 4. And that would be the new y value of m dash dash, which is like that new m coordinate, but on h, on the graph that was translated, or that graph that underwent transformation. Thank you everybody for this. We're done with this question. This is question 4 of the June 2019 Nsc paper, math paper 1. I thank you.